So if you're asked a question on half-life, you should know the general form for an exponential relationship. That f of t is equal to k times a to the t power. Okay, this little equation governs the whole relationship. So real quick definition of each of the terms. F of t, this variable, represents what's left over after a certain amount of time, like how many grams are left over. K represents how many grams you start with. A is like an exponential rate, and T is the amount of time that you elapse. So the big thing you want to start by finding out is finding out what A is. Okay, so they say we start with 10 grams, and they say that half of it's left over after 25 years. So let's plug that in. That's what she looks like because I plugged in 25 in for T, and if I started with 10 grams, I should have half of 10 grams left over after 25 years. So that's what it looks like when you plug it in the equation, and now we can solve for A. And just a quick note, I haven't even talked about any of this other stuff here. I stopped as soon as I saw that I had the information for half-life, because as soon as you're told the half-life of an element or an isotope, then you can find A. And so you should wait before doing everything else until you know what A is. So divide 10 from both sides, because that's 10 times A. You can easily get rid of 10 by dividing it from both sides. And you get 1/2 equals A to the 25th power. So as A is being raised to the 25th power. To get rid of that 25, you're going to raise both sides to the 1 added 25 power. That's a balanced step because we've raised both sides to the 1 added 25th power. And the reason why we did it is because a power on top of a power multiplies. So 1 added 25 times 25 makes A to the first. So we just need a calculator for 1/2 to the 1/25th power. And decimal places are pretty important for exponential relationships, so you probably should try to carry it even more than what I did here, but that's hard to write with my finger. So now we have the exponential rate. Let's see what the question's asking us. They're saying 10 grams disintegrates over a period of 43 years. We're really asked for how many grams are left after those 43 years. So let's go right back to our exponential equation. We want to know how much is left, f of t. If we start with k equals 10 grams, and if we have our exponential rate here of 0.97265, and then we're looking to find out how much is left over after 43 years. So 43 goes into t of that equation. And so now this is something you can just plug through the calculator. You should do the exponent first and then multiply it by 10, and that will give you f of t, the amount that's left over after 43 years. And really, with function notation, I should be putting 43 in here to say that we put 43 in for t. But yeah, with a calculator, this to the 43rd power times 10, we got about 3.04 grams. And that makes sense, too, because they said that half of whatever we started with should happen after 25 years. We've gone almost double that many years. So it should be less than 5 grams for sure. And we're at 3.04 grams. So that makes sense in that context too. But this is your answer. 3.04 grams are left.